All right, continuing here. So we're looking for one factor positive and one factor negative. So what numbers do we think it is? Interesting issues I'm having here. Which numbers look to have a sum of 4? Well, -1 plus 60 would give us a sum of 59. -2 plus 30 will give us a sum of 28. -4 plus 15 gives us a sum of 11. -6 plus 10 gives us a sum of 4. And -5 plus 12 gives us a sum of 7. So none of these gave us the sum of -4, which we need because the b value here is negative. So I'm going to focus on the numbers that gave me a positive 4. If -6 times 10 is positive 4, I'm going to try switching the negative sign. Maybe it's 6 times -10. And sure enough, 6 minus 10, or 6 plus a -10, would give us a sum of -4. So if you find the numbers that, when combined, make b, but the sign isn't right, try switching the sign. The answer here is going to be x plus 6, x minus 10. And you could switch it and write x minus 10, comma, x plus 6. But what's important is that the 10 is negative and the 6 is positive. -10 times 6 is -60, and -10 plus 6 is -4. Let's go up and see if we can match number 6 with x minus 10, x plus 6. There we go, matches to letter G. All right, looking good. Let's keep going here. Number 7. We need to multiply We're going to multiply to -15 and add to -2. So, okay, I'm thinking what? 1 times -15, 3 times -5. And what would those sums be? 1 plus a -15 would be -14, and 3 plus a -5 would be -2. All right, so that means 3 and -5 work. I'm going to put those in parentheses with the variable x, and this is our factored form. And these are equivalent. Maybe I'll pause for a moment and just remind you the reason this is the same expression. If you were to check it, and you can check every factored problem, when I multiply x by x, I get x squared. X times 3, I get 3x. Negative 5 times x, I get a minus 5x, and negative 5 times 3, I get a minus 15. Now if I was to rewrite that check in standard form, I'd have x squared, 3 minus 5 in the middle, combining like terms would be minus 2x minus 15. Now this check isn't required, but it is an option. When you multiply and check, you get the same thing you started with. You can check any of the problems on this entire handout this way, and you should get exactly what you started with. Okay. Going back to matching. So number 7, x minus 5, x plus 3. H. Man, these are going really straight. Number 8, we're going to multiply to -6, add to 1. When there isn't a number as a coefficient, that means there's an invisible 1 in there. B is 1. So what numbers will multiply to -6? We have 1 times -6, 2 times -3. Let's try adding those. 1 plus -6 is -5, and 2 plus -3 is a -1. I'm trying to add to +1, so I'm going to take a closer look at these values. When they add, they get to be -1, so I'm going to try switching them. -3 times 2. -3 plus, that's not what I meant. That's not what I meant. Those are the same options. Try again. I'm going to try switching the signs. -2 times +3. -2 plus 3 is a +1. So that's what we're looking for. Again, if you add your values together and it doesn't have the right sign, try switching, making the other value positive or negative. So x minus 2, x plus 3 is our factored form. Let's match that up. Number 8, x minus 2, x plus 3. Huh. I think it goes with I here. I'm gonna edit this. X minus 2. Watch this. I'll have this edited for you. It's a minus. Okay, so number 8 matches with letter I. That'll be right on yours. Okay. Alright. Plus 2 minus 3. Number 9. We're doing well. Again, in number 9, we want to multiply to -20. And we're finding a sum of +1. That's because there's an invisible 1 in front of the x. So we have 1 times -20, 2 times -10, 4 times -5. Can't think of any other numbers that multiply to 20, so I'm going to find the sum of these factors. First, I get a -19, -8, -1. Okay, 4 and -5 make a -1, so I'm going to try switching the signs. -4 times a +5 is -20, and -4 plus 5 has a sum of 1. So -4 and 5 are our factors. All right, let's see if that answers there. Number 9, x minus 4, x plus 5. There it is. Okay, let's keep going. 3 more. Man, I'm excited. Okay, number 10. We need to multiply to 21 and add to 10. So we have 1 times 21 and 3 times 7. Let's add those up. 1 and 21 are going to make 22. 3 and 7 make 10. Yay. Those are our factors, x plus 3, x plus 7. And if I'm going too quickly, you always have the option to pause the video. Is that here? X plus 3, x plus 7? Oh, look at that. Letter F. Number 10 goes to... Why isn't it letting me write? Better let me write. Number 10 goes to letter F. 2 more. Oh, I didn't write the last 2. Alright, 3x squared plus 21x plus 30. Okay, I wanted to leave a lot of room for this problem. Number 11, 3x squared plus 21x plus 30. This is a special expression, and that is because it has a greatest common factor. And greatest common factors are really helpful to identify because they make your whole problem smaller. So when I look, this problem is different than the rest because there's a number in front. There's a 3 instead of the invisible 1. And then when I look at all of the numbers, I see that all 3 of the numbers, the terms here, could be divided by 3. So I'm actually going to factor a GCF of 3 out. We practiced this last week. Factoring a GCF of 3 out will leave us with x squared plus 7x plus 10. It's like dividing every term by 3. Now that a GCF has been factored out, I'm going to continue and I'm going to factor what's left in parentheses. So this is really special in that it has to be factored in 2 different ways. So I need numbers that will multiply to be 10 and add to 7, and that's going to be 5 times 2. That multiplies to be 10, and 5 plus 2 is 7. So I'm going to put those factors in parentheses, x plus 5, x plus 2, and I'm not going to forget the 3 out front. The GCF of 3 is still in the factored form. Let's see if we can match that. X plus 5, x plus 2 with the greatest common factor of 3 in the front. Okay, and that leaves you with one more problem to do on your own. Make sure you turn this into Schoology. Thank you.